Corporate finance practice problem using Excel. Internal rate of return, the IRR, problem 1. Get ready, it's time to take your chance with corporate finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet and would like to follow along, note that we're on the practice tab as opposed to the example tab. The example tab in essence being an answer key. Information, left-hand side, populating that information, blue area, right-hand side, focusing in on the internal rate of return, the IRR or the No one really calls it the but it might help you to memorize it. The IRR, the internal rate of return. You can kind of think of it as the inverse of the net present value calculation. Therefore, we're going to be putting these two calculations side by side. The IRR, internal rate of return, the is probably the most complex for most people to understand on these kind of present value calculations when you're looking at a project. But if you connect it to the net present value and do the internal rate of return next to it, I think it starts to make more sense, and that's what we'll do here. So it might take a little bit of time to kind of get this internal rate of return. Also note that prior to Excel, it was more complicated as well because, you had to figure it out in using a financial calculator or something like that, whereas Excel is going to simplify the process and we can kind of learn it conceptually in this way. So we're going to have the project cost. We have this same kind of scenario. We're putting down an initial investment, we're saying, of the $100,000. The cash flow per year, we're going to say, is $14,000 for 11 years. So we're going to get back then $14,000 per year. We're going to say then for 11 years and we're going to put down up front the $100,000. So then the question, of course, is, well, should we take on this project or not? Typically, we're using time value of money type of calculations to think about something that's going to impact this far into the future. That would be the net present value or the internal rate of return. What comes to most people's mind is probably the net present value first, in which case you might have basically a discount rate that we would be assuming, and then see if we present value the calculations here, if we would come up to an amount that would be beneficial or not. In other words, we would choose a discount rate. That would be basically our minimum rate of return, kind of the hurdle rate sometimes it's called, that we have to clear. And then if we present value our calculation and we come up with something positive, then we would expect that that cleared the hurdle rate and therefore something that we may then pick up. In this case, we don't have a discount rate because that's kind of what we're looking for. We're trying to say what is the basically kind of the discount rate or the required rate of return. What's the rate that would make this cash flow equal basically zero. So we can calculate this a couple different ways. Let's first go to the net present value type of calculation and use our goal seek to basically back into the internal rate of return, because I believe that's the most intuitive way to do it. And then we'll do it with basically the IRR formula, which we have in Excel. So let's just use our goal seek and assume. We're going to say, I'm just going to net present value this thing. I'm going to just assume a rate. Let's make it 0.05%. 5% is going to be the rate, or 5%, not 0.05. 5% is going to be the rate. Let's just present value this thing and see what we get to with 5%. And then I'm going to use goal seek to change the end result to be 0 by then relying on this rate. And that will give us, in essence, our internal rate of return. So let's do this. We're going to say, all right, we're going to say from year 0, 1, 2, this is our net present value calculation first. Going to grab these. I'm going to drag them on down. We're going to have 11 periods, 0 to 11. Going to go to the alignment and center those. And then we're going to start off with the investment, the initial investment. I'm going to represent as a negative number, negative of that 100,000. So that's where we start. Let's make this a little larger so we can see it. And then we're going to have our cash flow, which will simply be equal to that 14,000 each year for 11 years. I'm going to F4 to make this an absolute reference, putting a $sign before the B, and 5, allowing me to just copy it down. So I'm going to say enter, putting my cursor on that 14,000. I'm just going to autofill that down because that's what we expect to receive each year for the following 11 years. 11 years here. And this last one, this should be the total. This should be the total. And I'm going to left align that there. Okay, and so if I underline here, we're going to go to the font group and underline without the present valuing. This equals the sum of these items. That means that we're going to have 54,000 out if we do not take into account the present value. Present value, however, quite important given the fact that we're going fairly far out into the future here time value of money having a big impact. So we're going to say, all right, let's present value these. I'm going to use this rate to first present value and then find the rate that would make this stream of payments 0. So let's go back up top. I'm going to present value the first one, even though it's at time 0, and I'm going to come up to the same 100,000 because that allows me to copy it down more easily if I wanted to do that. So let's do a couple of these and then we'll copy them down. Negative present value, shift 9. We're going to present value the rate, which we're assuming is down here, that 5%. If I want to copy this down, I would have to make this an absolute reference. Note that this rate is outside the table. Anything that's outside the table, that's typically the one that you might have to make an absolute reference for if you want to copy it down. But I'm not going to do that yet. I'm going to say comma. And the next one is going to be the number of periods, which in this case is 0. So we're not anywhere out yet. Comma, comma, because it's not an annuity, therefore no payment. But present value of 1, future value is going to be that 100,000 and enter. Note that I did put a negative in the start, so it keeps it the same sign basically is why. So nothing really happened, but we could then copy that formula down if we wanted to, which we'll do later. Let's do it again. Negative present value, shift 9, rate we're assuming is that 5%. Not going to make it an absolute value yet. We're then going to say comma. We got the number of periods is now 1 period out that we're pulling back to the current day, comma, comma. Future value now is the 14,000 that we're pulling back. Now we're saying it's equivalent to the 13,333 at that 5% discount rate. Let's do it for 2 years out. Negative present value, shift 9, rate is going to be the 5% again. We're then going to say comma. Number of periods is going to be 2 years out now, comma, comma, because it's not an annuity, but present value of 1, 14,000 being the future value. Now that 14,000 2 years out has a present value of the 12,698 using that discount rate of the 5% that we just basically guessed at. Negative present value, let's do it again. Let's do it again. Why? Because it's good times to do it again. That's why, because it's fun. Comma, number of periods is going to be 3 years out this time. Comma, comma, because we don't have a payment, but future value, not an annuity, 14,000, bringing it back. Now, obviously, these going down as we go further out into the future, although the payment is the same, present value goes down. So let's go ahead and copy this down the rest of the way because I think we got the picture. I'm going to delete these 3 just so we can see how we can copy the first one all the way down, making this very easy calculation. Excel really, really nice in this area. You should really appreciate it. And then we're going to put our cursor in the rate column because that one outside the table, we need to make that one absolute. We're going to tell Excel, do not move that down. Don't you move that down, Excel, when I copy it. And so we do that by selecting the F16 and selecting F4 on the keyboard, $ before the F, $ before the 16, making it absolute. You only need a mixed reference, but absolute works, and it's easier, I think. I'm going to put my cursor on the fill handle now and drag it on down, and there we have it. Double clicking on one of these down here just to see if it does what we think it should. It didn't move that cell down. See, it's because I told Excel with authority not to move it down, and I did the absolute reference thing, which helped too. So then we're going to go to the font group and underline, and then we'll sum this up equals the SUM, summing this up. And that's going to give us our value. So if our discount rate was 5%, then we would have cleared that discount rate. Now, note that discount rate, we might be saying that the discount rate includes, the rate of return that we want, right? So that would mean that anything that was above 0, if that's how we were using it, if that was our hurdle rate, if that was our minimum return, then that would be taken into consideration both inflation and our opportunity cost, other opportunities that we can put our money in. Then anything above 0 is something that we would consider putting the money in. And this one, of course, is above 0. But that's not what we're looking for here. We're trying to get what this rate would be to get this flow of payments to 0. So now we could say, okay, Excel, let's use goal seek to basically change this cell. I want you to change this rate to whatever it needs to be in order to make this stream of payments 0. So we can use the goal seek to do that. Let's seek the goal. To seek this goal, we're going to go to the Data tab. We're going to go to the Forecasting What If analysis. What if this cell set the cell, we want to set this cell to be 0 by changing this cell. So once again, we want to make this cell, the series of present value payments, 0, which we have to hard code by meaning type the number in there, by changing this cell, the percent. And then Excel will just do it manually, like changing this cell will just be like us changing it by hand until we get to this number 0. So it's just going to force it. So we're going to say, okay, and then it does it. So about, it's still an estimate, but if you add 2 decimals percent, about 7.99. So that means this is about 7.99. So this is another way we can kind of compare different projects. Instead of using the hurdle rate and seeing how far above the project is, if we were comparing different projects, we could then compare the internal rate of return for different projects. And obviously, the higher the internal rate of return would indicate that it would be a better project. So another view at it, this internal rate of return, also very good because it does take into account the time value of money. So when you're thinking about options for analyzing which ones are the best, you're thinking about the ones that take into consider time value of money. That includes internal rate of return and the net present value. Let's do this with the Excel function to do it now here. So this is, instead of backing into it with GoalSeek, we could do it with the function. Now to do it, I need to set up the flow of payments again. So I'm going to do the same thing. So if I wanted to calculate the IRR, I'm going to do my same kind of payment flow, which would start at 0 and then 1 and then would go to 11. So we would do the same thing, doing it this way. And then total those up, go into the home tab, alignment, centering it, and then total typing. And then this is going to be negative cash flow of the 100,000 that we put in. And then of course we'll do the same thing with the 14s all the way down, 14 all the way down. I'm going to make it an absolute, telling Excel, don't you move that cell down when I copy it, because I want that same 14. F4 on the keyboard, $ before B and 5. You only need a mixed reference, but the absolute works. Grabbing the fill handle, dragging it down. There we have it. Let's put an underline on this last one. Font group underline, sum it up. Drag it down, sum it up. That's what we do in Excel. Drag it down, sum it up. So now we're summing it up. And that gives us our 54,000 again. Now we're just going to use our IRR formula, the internal rate of return formula. And that's going to be, let's say, that's going to be then the negative IRR, shift 9. And all we do is just grab the values now. It's kind of like the sum function formula, really easy as long as you set up your series of payments here properly. So it's all set up and we just grab those just like the sum function. I'm not going to grab the total, just grabbing those ones. And then boom, that's it. That's all you have to do. And it does it. So then notice it's of course been percentified. I shouldn't have put a negative in front of it. I don't need the negative, just equals that. So let's do it again, just to practice it again. No negative, equals the IRR of these, summing them up just like the sum function, or grabbing them just like the sum function. And then that's it. That's all you have to do. And so there it is. And because it's kind of magical that way, the Excel did it magically there, people often don't understand what that means. But that's the rate that you need to make this series of payments, if present valued using that discount rate, to be 0. So that's kind of like if you were comparing this rate to another rate of another project, you would like the internal rate of return to be higher, right? You'd like a higher internal rate of return. And that, because that would mean the project is, doing better, right? Because within the discount rate, when we're talking about a required rate of return, we're typically considering the opportunity cost of something else that might be taken into consideration. So that's a good way to do some comparisons. If we did the net present value, you're often looking at multiple projects that you might want to be putting money into, choosing a hurdle rate, and then any project that is over the hurdle rate, positive in nature, then could be a project that you want to invest in. And then you might be comparing multiple projects, and you might say, okay, well, what is the internal rate of return? What rate of return are they giving us? What rate of return would make the series of payments 0? And you can compare those out, and obviously the higher internal rate of return would be better. If you compare multiple projects using the net present value and just one standard hurdle rate, then obviously any project that has a higher number, like 1 is 0, if it was anything above 0, then you'd say, well, it clears the hurdle rate, and therefore it might be something we invest in. But if you compare two projects and you're only going to invest in one of them, and that might not be the situation. You might have enough money to put in any project that gives you a return that's above a certain threshold. You might be willing to do it, but you only look for projects that are above that threshold. Or you might be saying, well, I can only put money in one or two projects, and these two projects are both above what is my minimum rate of return, the hurdle rate. And so when you compare the net present value of them, then obviously usually you want the one that's going to be a higher number, the one that's higher above 0. But it could be useful, again, to compare them with the internal rate of return and then look at basically what rate, if you use that rate, would give that series of payments back to 0. And that would be like your discount rate or your minimum rate of return or your rate of return kind of calculation rate.